everyone. Here is question number 2 from the AP Calculus AB exam in 2025. And check out my description below where I've provided links for the other 5 FRQs from the 2025 exam. All right, so let's get started. It says the shaded region R is bounded by the graphs of the function f and g, and we are given the functions f of x and g of x as shown in the figure. And I love that on this year's AP exam, they did give a note that says your calculator should be in radian mode. And that's important for this one because g of x does contain a trigonometric function. Part A says to find the area of R and show the setup for our calculations. So for this problem, I would set up the area of R like this integral right here. So we are finding the area from the x value of 0 to the x value of 3. And in this case, we would need to do the top function minus the bottom function, or g of x minus f of x dx. And on the exam, you can leave it exactly like this, but I did want to show you what I did type into my calculator because I anticipate that there may be a common error made here. And that is when you subtract the function f of x from g of x, you do need to put f of x in parentheses, because without parentheses, your answer would be different. So this is what I typed into my calculator, this integral right here, and I got the answer of 5.136 or 5.137. Either answer would be accepted. You can either round or truncate. You just need to make sure to include at least 3 decimal places. In part B, it says that region R is the base of a solid. For this solid, at each x, the cross-section taken perpendicular to the x-axis is a rectangle with height x and the base in the region R. And we need to find the volume of the solid and show the setup for our calculations. And so I've drawn my best rendition of a 3-dimensional rectangle. So you can see the base of the rectangle is in region R, and then the height, just imagine that coming out towards you. And so when I set up my integral from the x values of 0 to the x value of 3, I need to think about the area of a rectangle is base times height. And so the base, which is in region R, would be the top function minus the bottom function, or g of x minus f of x. And then the height of this rectangle, as it says in part B, is that the height is x. So this would be the setup, as you see here on the screen in green. But I did want to show you what I typed in my calculator, which is this right here. Again, make sure to use those parentheses around the function f of x. And then it's the entire quantity of g of x minus f of x that's being multiplied by x. So just be careful how you type that into your calculator. And I got an answer of either 7.704 or 7.705, depending if you round or truncate. So either answer would be accepted. In part C, we are asked to write, but we don't need to evaluate an integral expression for the volume of the solid generated when the region R is rotated about the horizontal line y equals -2. So I started by drawing in this horizontal line, or the axis of revolution, in this case, or the line of revolution here. And I know that as soon as I take a 2-dimensional figure and rotate it, I either have disks or washers. And in this problem, since there's a gap between the region and the axis that I'm revolving this region around, I know this is going to be washers. So I have to think about what is the large radius and what is the small radius. The large radius is going to be top minus bottom, or the top function g of x minus the axis of revolution, which is at -2. So notice here that I gave capital R would be g of x, which is x plus sine of pi x, minus -2. Again, I anticipate there might be some mistakes here. So when you simplify, you would have x plus sine of pi x plus 2. And it is absolutely okay to just leave it as g of x plus 2. So I just wanted to make that point. Now the small radius would be the closer function minus the axis of revolution, or f of x minus -2. f of x is x squared minus 2x, and then you're subtracting a -2, which turns into plus 2. Once again, it is absolutely okay to say f of x plus 2, since f of x is defined in this problem. So now that I have my large radius and my small radius, I can put that into the integral. Because these are washers, we have circles. So it's essentially pi large radius squared minus pi small radius squared. And you can factor that pi out in front of the integral. So we would have that the volume is pi times the integral from 0 to 3 of the large radius squared which is g of x plus 2, or x plus sine pi x plus 2 squared, minus the small radius squared, which we already calculated was f of x plus 2, or x squared minus 2x plus 2 squared dx. And this one we did not have to evaluate, so as long as you have that set up, you are good to go. And then lastly, part D. It can be shown that g prime of x equals 1 plus pi cosine pi x. We need to find the value of x that's between 0 and 1, at which the line tangent to the graph of f is parallel to the line tangent to the graph of g. So what are we really doing in this problem? We are essentially being asked, where is f prime of x, which is the line tangent to the graph of f, parallel, so we're talking about that slope, which is f prime of x, is parallel to the line tangent to the graph of g, or g prime of x. So you have to read that and kind of interpret that that's what you're looking for in this problem. F prime of x is something that I need to find, and I can just simply use the power rule to find f prime of x. Since f of x is x squared minus 2x, f prime would be 2x minus 2, and I need to find where that's equal to g prime of x, which is given to you in part D. Because this is a calculator problem, I 100% used my calculator to solve this. I would never solve this by hand. And the way that I solved it in my calculator is I set the left side, or in my calculator, I put the left side of this equation into my Y1 in my TI-84 Plus graphing calculator, and then I plugged this side into my Y2. I changed my window to go from 0 to 1, and then I found the intersection point. And on the calculator, that intersection point was either 0.675 or 0.676. Again, whether you choose to round or truncate your answer, just make sure to include all three of those decimal places. All right, that's it. Number 2 from the 2025 AP Calculus AB exam. I hope you found that helpful.